Dear students, see that next question from the 9th standard motion chapter, Ncert exercise problem number 7. Okay, please listen. A ball is dropped gently from a height of 20 meter. So height is given. Okay, if its velocity increases uniformly at the rate of 10 meter per second square. Okay, with what velocity? So velocity asking, with what velocity will it strike the ground? Okay, as well as after what time will it strike the ground? So now they are asking velocity while it is striking the ground. What about the velocity and then time asking? Okay, see that. So let us imagine. Let's take one ball. Okay, see that. What question? The ball is dropped gently. Dropped gently. Just I leave it. That's all. So just leave it. So no need to give any initial velocity. So in this condition, the initial velocity is 0. Here initial velocity what? 0. Then let us imagine it is the ground. While it is touch the ground, what about the velocity? While touching ground, what about the velocity? As well as what about the time curve? Okay, so what about the velocity? And then what about its duration take from the leaving position to and reaching position? That's the question. Okay, so now see that then how to approach this solution. So let's take one object. Okay, now I can leave this object. Now in this position, initial velocity 0. Now it is the ground. Okay, now I leave that. So it will reach the ground. Okay, so while it is reaching the ground, due to reaching the ground, reaching the ground, the initial the final velocity is what? That is the velocity. Okay, while reaching the ground, what about the velocity? As well as this time taken to reach the ground. Okay, from the top to then and end position, what about the time duration? Okay, this is a question. So now that velocity counting question, I can take as a question number A. So I want to count the velocity. So here what are the values given? Actually the height is given. So height is equal to 20 meter. Then acceleration is given. That acceleration that is a 10 meter per second square is given. That's all. Okay. So the first question, what is the velocity? So B is asking. That is the first question. Second question is time asking. Okay. First velocity. So here there is a relationship between height and velocity. Okay, remember this formula from equations of motion, that is v squared is equal to u squared plus 2as. S is nothing but displacement. It is displaced from this position to here. So I can taken as this is like a height. Okay, this I called as a height. Okay, so here s is nothing but taken as height. Then initial velocity is 0. So this time will be 0. So I can write as v squared is equal to, this time is 0. This s is right, you can write as h. So we can write 2ah. Okay, now asking v only. Therefore v is equal to, square is moving that side, become root. That is root of 2ah. Therefore v is equal to whole root of 2 into, what about acceleration? Acceleration is 10. What about the height? The height is given as 20. Therefore v is equal to whole root of 2 into 10, 20. 20 into 20, 400. So root of 400 I can write as that is 20. So 20 meter per second. So this object or this ball, I leave this while it is reaching the ground. Okay, while reaching the ground, here the velocity was 20 meter per second. So next B question, to calculate the time. So something initial velocity is 0. Okay, anyhow initial velocity and final velocity and the acceleration is there, then time factor asking. So we have to calculate in a time factor in two ways. One is, what is it, s equal to ut plus half at square, or otherwise v is equal to u plus at, any formula. So I can use v is equal to u plus at. Okay, v is equal to u plus at. Otherwise I can write, okay, therefore at is equal to v minus u. Therefore t is equal to v minus u divided by a. Okay. Therefore t is equal to v value already we found, that is 20. minus initial velocity 0 divided by acceleration is given as, what is it, 10. So that is 10. So t is equal to 20 divided by 10. 0, 0 cancel. So t is equal to 2 seconds. Okay. So now the object to reach the ground in 2 seconds. Okay.